Okay, edit distance as alignment. So there are many ways to do alignment, right? And we need to figure out what is the cheapest one. So let's look on the different prices in this case. So in this case, we have to pay one, right? This is a change column, and this is it, right? This is an insert column because we insert the letter C, and as such, this is going to be the cost. If we are using the non-uniform metric, right? Delta for gap, well, insert, and this is the cost for moving from A to E. Okay, there is of course an alternative where it might be cheaper to insert the C and then delete the E and then insert the A. But of course, there are a lot of other possibilities. Here's the most stupid solution, which is of course the way most of us would do it probably. You just delete the word, right? So you align the first word with empty columns, right? This is all those columns corresponds to delete. You delete the first word, and then you have insert column for the second word. So you just insert it, right? And now we have those possibilities, and we want to choose the price between them, right? And there are a lot of other possibilities of doing this alignment, right? If you think about it, the number of possible alignment is quite large. Okay, so as an example, let's look on those two strings and ask what's the alignment cost between them. We're 373 and 473. Okay, so let's think about it. Okay, let's start from this. 374 and 473, which of course is reverse of each other. So in this case, it's easy to convince yourself that in fact, this is just the optimal alignment as it is, which is 2, right? Because 4 goes to 4 and 3 goes to 3 and 7, well, because we are not allowed to flip, right? So 3 goes to 4 and 4 goes to 3. So you have 2 change columns, so you have to pick 1. And this is the optimal you can do, unless, as I mentioned earlier, you have a more advanced edit variant where you're allowed to flip string, which is not a case we are going to consider. So this is 2. And this is the 373 and 473. And clearly the edit distance in this case is 1 because the two other columns are equal. So this is two cases that are not very interesting. Maybe let's see a more interesting version. 37 and 473. So let's see what's the best alignment. Well, there are two natural alignments, right? 3, 4, 7, 7, 3, right? So this is 1, and this is 1, and this is 0, because this is an insert column. This column is an insert column, and this is a change column, so this is going to be 2. And we cannot do any better, right? Because the fact that 3 and 3 are not there is not helpful. But let's try to maybe think about it more systematically, right? We have 37 and 473, right? And think about their alignment, right? There are many possible alignments, right? There is 3, 4, 7, 7, I don't know, 3, right? Now, you have to remember that we are not going to have columns that are empty, right? Every column must contain a letter from one of the strings, right? Because otherwise, if it's empty, you can just delete it, right? So the number of columns we are going to have is at most the number of characters in the two strings. Okay, so that's the first observation. The second observation is that since we must have a letter of a string in every column of this alignment, we might as well look on the last character, right? And you can kind of think about what are we going to do with the last character, right? In this case, we cannot do anything because 3, unless we delete the 7, which we're allowed to do, by the way, we can definitely do the following alignment. Let me do this alignment, right? 37, 4, 7, 3, right? This is definitely a valid alignment. Here we're aligning the 7 against space, so we have to delete it. This is 3, and then we have to pay. So this cost is 3, which is worse than 2, of course. So that's that, right? Now, the problem is that intuitively, the number, as I said, the number of alignment is quite large. It's exponential, right? But the important thing in some sense is that think about this alignment. If I decided to align 7 with nothing, right? If I decided the left column, then really what happens to the left of this column, whatever it is, it's an alignment of the string 3 with 473, right? This is an alignment which has to be optimal. And this is really what's going on. What's really going on is that we locally need to make the alignment optimal, but then whatever comes before that also has to be optimal, which means that in some sense, although the number of possibilities is huge, we don't really care about all possibilities. We care only about the optimal possibility on the prefix. And this number of possibility is 1. So if you want a high-level intuition about why this problem can be solved efficiently, this is the reason. Okay, so that was an example. Right, so the sequence alignment problem formally is I give you 2 sequences and you want to align them under this pricing of delta for gap and an exchange price for replacing a letter by letter, and you want to find the optimal alignment. Now, this, as I said, this alignment problem, string alignment problem or sequence alignment is in fact a widely used problem in practice, and you can use quite large inputs, right? If you do diff or even sequence alignment, you're sometimes speaking about millions of letters. So you really want something efficient to be done about it. And right. And we would like to do the best we can do. Okay. And, here it's mentioned various limitations and so on. This is about performance. This is for the algorithm that I'm going to present shortly.